So the two main lines of research I pursued during my PhD are how to verifiably export data from centralized websites. So this would, for example, allow you to do things like prove your bank balance is so and so. But this is not what I'm going to talk about today. I'll be talking about proving geolocation. And that is that will be the focus of the talk, but if you're interested in the other thing, we can talk later. Let's get into it. So here are some motivations I've collected. These are some motivations I've collected before reading the book. I'll have to update them later. First of all, so the primary motivation for us was how do we prove the location of a file? And this question, we were interested in this question in the context of decentralized storage systems like Filecoin. In particular, this would improve robustness of the storage. If you can prove, for example, that a file is replicated by saying that one copy of it is in North America, the other copy is in Asia, the other is in Australia, that's a natural way of proving that you have multiple copies of a file. It also has applications to verifiable CDNs. If you can prove that a given file can be retrieved quickly at any given location, that in a nutshell is the point of a CDN. They're trying to deliver files or content in particular geographies. But this has more applications than this. I'm also excited about applications related to proving the location of an identity, where an identity could be a cryptographic key. Something here I'm interested in is things like geo-elections. Can we conduct an election based on their location? Can we just do a digital voting here based on people at 192 Museum Way? More abstractly, there's also the challenge of proving location of an arbitrary computation. To be clear, we don't tackle this. This is much harder, I think. But this would also be, I think, a very useful tool if doable. Okay, with that said, I'll jump into it. Future work. So just a quick note on existing technologies. The bridge we're trying to build is to build technologies that allow you to prove your location. And existing technologies like GPS tell you your location, but there's no way for you to prove that to someone else. And that is kind of what we're trying to do here. In the interest of time, I'll only be focusing on proving the location of a cryptographic key. I won't be covering the second bullet here. But the techniques are fairly similar and they extend in a similar way. I can talk about them later if someone's interested. So now I'll sort of switch into a little more technical side and give a little bit of an overview into how we do this. Now the key technique is something called distance bounding. It's a fairly standard technique. It's used even in GPS, for example. Say you have a verifier and a prover. We assume that the verifier is located in SF, and let's say the prover is trying to claim that they are also in SF, which means that they're presumably close. And the point is the verifier takes a clock, sends a challenge, and basically measures the time it takes for the prover to respond. And if the response time is small enough, then that means that the distance between verifier and prover is close, and therefore the prover must also be located in a nearby location. So it's a fairly simple idea. That in a nutshell, that is the idea we extend even in GoAT. Now, a key challenge here is to ask this question of, well, who is this verifier, and I sort of assumed that they were located in SF, but do we really have a verifier located in SF, and how do you bootstrap that? That is the crux of the concern we attack in GoAT. At least one of the concerns we attack in GoAT. So how do we solve this bootstrapping problem, right? We clearly need geo-distributed verifiers. By that I mean verifiers located in different locations to be able to do geolocation, but they aren't there today. And in particular, one thing we do have today is there are millions of websites out there. Think of local businesses, think of random web servers out there that are already geo-distributed. So we were in particular interested in asking, is there any way we can leverage them as our verifiers? And in a nutshell, the answer to that is yes. It's not a complete yes. We can't leverage every single server out there. There's particular characteristics of these servers that we need for them to be called what we call anchors in GoAT. And the two features we need of them are, one, they need to provide authenticated time. I'll explain what that means, have no location. And the idea is that an anchor accepts as input a random piece of data called a nonce. So this is the API I'm looking for in these servers, basically. And it needs to return the current time together with its digital signature. The signature is computed over the time and the nonce. Signatures are, as you probably know, publicly verifiable, so anyone can just look at the signature and be convinced that A, it comes from the anchor, and also they'll be convinced that that the time is so and so. And it turns out that there are, in fact, many servers out there that satisfy this API. In particular, TLS 1.2, sorry, servers that use TLS 1.2 have this API within them, which is whole another story I won't get into. But the good news was that we have the server. So now, how do we use them? And the idea is fairly simple. So let's say you have a prover, we have an anchor. Again, the story is similar. We assume that the anchor is in a particular location. The prover is trying to prove that it is close to the anchor, thereby proving its location. It's a three-step protocol. We ping the anchor. So we use the signature received from the anchor as a challenge, and the prover computes a response. The response is included as a nonce in the second ping. And the proof of key location is nothing but the pair M1 and M2. So these are the two anchor transcripts we've received. Okay, why is this a proof of key location? Anyone can just look at this and first of all be convinced that this is coming from the anchor because of the signatures. They can subtract the two timestamps, T2 minus T1, and be convinced that this operation that was performed in between was performed in a short enough time, and the only way that would have happened is if they were actually located close to the anchor. Again, I'm not going to go into the details of how these thresholds are set, but you can imagine that we have some sort of internet network model using which we determine reasonable thresholds for this computation. I haven't gone into the detail of what that yellow line is. In this case, for proving a key, this is nothing but a signature computation. That's how you prove that you are in that location at that time. Also want to quickly note that this is a way of time stamping, right? So you're not just proving that you are in that particular location, but you're also proving that you're in that location at that time because of the timestamps T1 and T2. Just a quick note on the results. They might not be as great as you might have imagined. So here's a prover, here's an anchor. And this huge circle is the radius in which the key might be. The reason this is happening is that we are operating over the internet, meaning that we need to build, our parameters are set to deal, our parameters are set so that even a honest prover can prove their location, but a cheating prover can always find the fastest network point. So for example, we assume that a cheating prover can traverse the internet at 3 times more speed than a honest prover. That is sort of why you see these huge circles. But we think that this is a good starting point. It already allows you to prove that you're in particular, let's say, East Coast, which suffices for many applications. Final thoughts. So GoAT allows proving file location. There's several avenues for future research, improving geolocation accuracy. So we assume that there is some sort of honest majority amongst anchors in a particular location. That's our adversarial model. Thinking about more incentives for anchors and things like that are all things to be thought about. And there I'll conclude my talk.
Wonderful. Thank you. We can take questions while I ask Steve.
Satellites.
Sorry?
Satellites.
Yeah, so satellites are a great idea. We weren't thinking of it. Satellites. So we need, the main challenge I see with satellites is that unlike GPS, where everyone just needs a receiver, here you also need to send the nonce, which means that we need software deployed widely that allows people to send data to satellites. I'm not a hardware expert. I don't know what that takes. I'll be interested to talk if there's.
How about cell tower protocols?
Cell tower protocols. I'm not exactly sure what you mean. So are you thinking about pinging cell tower protocols?
Exactly. Radio frequency, like light speed, no issues with multiple hops and random latencies.
Do you want to trust the cell network to?
Yeah.
It's what is used for geolocation right now. I mean, do you trust random websites?
Maybe. Interesting thought.
Great, you're already getting into some working groups. I like it.
What does GoAT stand for?
Geolocation via anchor timestamping. Don't ask where the O came from.
And final one, Mike.
Explain why you want to prove the data is located somewhere. I can think of lots of reasons you'd want to prove data was not located in a certain country, so you wouldn't have to obey their rules.
I see.
Why would you want to prove it is in their country?
So it wasn't more about countries. So we were mainly looking at ways to prove that your file was replicated. One way to prove that is by proving your file is in 3 different continents. So it doesn't really matter which country it is in as much for that application. But
So certain types of data has regulations on where it can physically be stored.
that would be another application.
Some diversity of storage is required.
Well, sometimes.
No, so sometimes there's regulation forcing you to store data in particular locations.
Like
That might be another application. Yeah, but that gets really messy.
Also, if you want to prove you decentralize something, it's great to know that it's actually in
Different locations.
rather than one location.
You said you're basing on TLS, which is sort of like a domain name based validation system, right? It could be a proxy certificate as well. So how do you overcome the proxy scenario? The actual server could be somewhere else, but the TLS can be generated.
Yeah. There's a bunch of problems that also come with TLS. There's the only way we tackle this is by sort of initially doing a measurement study of sorts to figure out which TLS anchors we can actually use. The more cleaner approach would be to use rough time, but there aren't as many rough time servers today. So.
Thank you. Okay, I see you have lots of